Hey guys, this is Tyler from Upstream Studios. In this episode, I'm going to be building a tilt top tea table, and I'm going to be incorporating a few things to kind of push this design a little further than I have in the past. What you've been watching is me not in my shop. This is my friend Kevin's shop. As you can tell by the awesome lighting and the flickering video, Kevin has fluorescent bulbs. Let's all forgive Kevin for his horrible lighting choices and move on. But nonetheless, Kevin has been gracious enough to let me come over and dull his tools. Or use his lathe. Anyway, I'm not here to teach you guys how to use the lathe. And if you're a turner, forgive me, just like we forgave Kevin for his horrible lighting choices. What you've been watching me do is turn a simple spindle that will make up the center column for this table. Dimensions on this are not super critical. The only thing that really matters are their overall length, about 20 inches, and the tenon that will ultimately be wedged to mount the hinge plate base thing. You'll see what I'm talking about later. And that's it. Now that I've got this column spindle thing done, I can mount it into this jig. This jig lets me suspend the column between 2 points and route out the flats and the female portion of the sliding dovetail that will connect the legs to the spindle. Once I've routed out both of those features, I can go back in with a chisel and clear out some of that waste so the leg can sit flat against that ring. You'll also notice as we go through this video that the continuity is shakier than Michael J. Fox's hand. I've filmed this over a period of 2 months or so, going between a couple shops to get the work done, so to make things easier to understand, I've edited this video in order of components rather than chronologically, just to make things a little easier to follow. This is me milling up the lumber that will make up the tabletop. There's nothing special here, just a simple panel glue up, but I do one thing that I think allows for a little tighter of a glue line, and that's using a hand plane to true up the edge. In theory, a jointer should leave a perfectly flat and square edge, but with the rotary action of a jointer's head, you'll always end up with ridges. You can mitigate that as much as possible by slowing down your feed rate, but using a hand plane over the joint seam ensures two perfectly flat surfaces join together, and you can almost completely eliminate any seam. And as you can see here, with just some light clamping pressure, I get a nice even bead of squeeze out the length of the panel. Now with the magic of video editing, the glue is dry and I can start cleaning off the top with a card scraper before laying out the circular top with this very large pair of dividers. Now I can take the top over to the bandsaw to roughly cut out the circle, and then take it over to the router table and using a 1/4 inch bit in the router table, true up that circle. By using a nail as a pivot point, I can drop the table onto that nail and rotate it to give me a perfect circle any distance away from that bit that I'd like. Now that the top has been turned from a square into a circle, I can bring it over to this, jig number 2. It's a simple jig, kind of like a router sled for flattening slabs, but in this jig the router stays secured to the sled, and I'll rotate the top using the same pivot point I used to turn this thing into a circle in the first place. I'm removing about 1/8 inch of material out of the center to create this dish profile, then going back to the bench I'll use a combination of files, carving knives, and sandpaper to turn that square lip I've left into a rounded profile. Now that the profiling of the top is done, I'll use the third jig in this video and route out a 1/16 inch groove to house some 14 gauge square brass wire. The jig is just an auxiliary base for my trim router with 2 points of contact so I can maintain a consistent distance away from the lip of this table. Once the groove is routed, I can inlay the brass into the top of the table, and the difference between the router bit and the wire is about 0.02 of an inch. This allows for a tight pressure fit, but I'll add a bit of adhesive just to be safe. Now that the top is finished, I can move on to working on the legs. I'll start off with some 5/4 stock milled down to 1 inch, and then using a template I'll trace out the shape of the legs and cut them roughly to shape out on the bandsaw. Once the legs have been roughed out, I'll take them over to the router table and with a flush trim bit mounted, I'll, well, flush them up. This here is a good example of why you should use paddles for smaller parts. Towards the bottom of the leg, I was getting some chatter and thought maybe if I nibble away with some small climb cuts, it'll help with that a bit, but it didn't. Use a paddle, you guys. With freshly changed underwear and a bit more caution, I could use a scrap to test out what would become the male portion of the dovetail for the legs. Now that I have a nice tight fit, I could bring out jig number 4, and I promise this is the last jig of the video. I think. This jig basically just allows me to hold the leg securely and squarely against the fence of the router table. This keeps the leg held securely to prevent any kind of tilting or possible gouging into the leg with that bit that's going a million miles an hour. Now, if you guys can remember back about 3 minutes to when I routed out the dovetail slots for these legs, that groove doesn't go all the way up to that ring at the base. And because it doesn't, if I were to try to seat this thing into that groove, I'd end up with a gap bigger than my appetite at a golden corral. So I'll cut off about half an inch at the top of the leg to let it sit flush with that ring, and I'm not really worried about a loss of strength here because 1, I still have a ton of surface area for the glue to bond with, and 2, the table isn't going to see a ton of use. It's more of a decorative piece and isn't going to be subjected to the abuse of something like a dining table or anything like that. Now that mechanically the legs are done, it's time to add a little bit of flair, a little pizzazz, if you will. Off camera, I've laid out the placement for these brass rods, and using a set of drill bits I had to purchase specifically for this application, because I did notice that these brass rods that I purchased were in metric, I'll drill out the corresponding holes, press in these brass rods, and then come back with a file and flush these up to the leg before hitting them with a touch of 320 grit sandpaper. I don't know if this really counts as a jig, but I'm going to for the sake of the jig count in this video. Because in case you didn't know, they do not make a router bit that will cut a 1/16 by 1/16 inch groove. Initially I was just going to purchase a bearing to replace the one that comes with this bit, but lo and behold they also do not make a bearing with the necessary internal and external dimensions that I needed. Luckily Jason over at Nordic Tool in Turlock, California was able to make this bearing custom for me to keep the ball rolling on this project. Now, after a little bit of tape and a little bit of epoxy, I was able to adhere the inlay into those slots before using the patterning bit in the router table to flush up the brass to the surface. Now that everything is flushed up and looking good, I can go back in with another router bit, this 22.5 degree chamfer bit, and break that square edge before coming back in with a card scraper to make sure that that chamfer goes all the way up to that inlay. Now that everything else is done, all that's left to do is make the tilting mechanism. Otherwise, this tilt top T-table would have no tilt, and if that's the case, then what's the point of this YouTube video? But anyways, I'll start off by ripping out some material for the table braces, and then move on to the hinge plate. This is just a 6x6 square with a rabbet cutout on one side to accept a 5/8 inch square dowel. This will get rounded off later, but before I do that, I'll have to flush these off with a hand plane and make sure that the tenon I turned earlier will actually fit into that hole that I drilled off camera. Now that the basic shape of the hinge plate is done, I'll mark out the round tenon using this cheap circle template you can find at any craft supply store, and round off those protrusions with some files and chisels. And that round peg will then go into a corresponding hole in the brace pieces. Now that everything functions the way it should, I'll start to make things pretty by adding some curves and rounding things out. J.R. Osgood once said that a straight line is just a missed opportunity, so I'll draw out some curves on the brace pieces, cut those out, and then using some rasps, spoke shaves, and this tiny spoke shave from H&T Gordon, I'll finalize the shape and sand all of these pieces off camera because let's be real, no one really cares about a sanding montage. I mentioned that I've made this tilt top T-table before. Twice, actually. One of those is in a corner of my aunt and uncle's house, while the other is at my friend Kevin's house. Yes, Kevin. The same one who let me use his lathe earlier and had the horrible lighting that we've since fixed. Thank God. So you might be asking, if you've made this before, why make another? And the simple answer is, because I think I can improve on the design. I feel like a lot of the time as woodworkers, we'll make a piece once, and then have a bunch of regrets. And I've been guilty of that myself. I'll finish a project, and then once I'm done, I'll look back at it and think, if I were to do it all again, I'd do these things differently. I feel like in order to fully realize a piece of furniture, to ensure that the form is as good as it possibly could be, it requires iteration. If a piece is going to be in your home, or even yet in someone else's home, wouldn't you want that piece to be as good as possible? With that being said, if you have the chance, try to make a prototype of the next project. Not only will you be able to use any information gleaned from the building of that prototype, but you'll be able to see the end goal, fully realized, and can make any necessary adjustments before moving on to that nice pile of lumber that your partner doesn't know that you bought. Anyways, that's enough of my rambling. Now that the finish is on, here's some final shots.